Hey guys, hello and welcome to a new video. This video will be longer than half an hour. I know this upfront because I will do the case ATM or in German Geldautomat by my fellow competitor Jean. It's a community case. I don't know if it's a free case that will be shared publicly, but yeah, if you're part of the community, you got this case. And yeah, I do this case, for example, to get into Jean's mind because he is or will most likely be the hardest competitor and most likely also the winner for the German Excel Championship. And yeah, I need to get into his mind to win or to at least have a chance to win. So without further ado, it's a case with German instructions and English instructions. I sometimes will most likely also go to the German instructions if I don't understand everything right. A little bit of data here, some bonus dependent data you should know. But here, first import lambdas. Now lambda import wasn't successful. Let's do it manually. Okay, because I will use my lambdas, but I have at least a bonus copy, some sort of. Okay, level 1. This is simply a division when I'm turning on the automatic calculations. 10 points, yay. This is basically a round down of a division plus half of the half of the value we divide by, and this multiplied by the amount because we want to find out the amount. No, this was wrong. No, this is way too large. 80,000 times. Oh yeah, of course. I need to multiply with h and not with the amount. Okay, makes sense. Now here I will first do this manually. So we withdraw this amount and we always start with the highest node possible and then going to the lower denominated node. Therefore, I first sort this by column and the other way around. And then I use a function to do this. So equals scan. We start with this amount. This is the array. Lambda b a minus round down a divided by b to the nearest number. Let's see what we got there. We get something odd. Multiplied with b, of course. Yeah. So here we get how many money is left, so to say. So if I drop then the last column out and add here the amount, then I know, okay, first I start with 2000. After the first round of nodes, I'm at 78 euros and so on and so on. And then I'm able to calculate this here minus this here and divide. Oh no, I should not have dropped this. Yes, I know you spill. I know. I can make this area wider. And now I know, okay, how many of every node or how much money I take from every node. And I can simply divide by the value of the node. And I get to the result. Okay, let's copy this stuff down here. Okay, there's something odd here. Yes. If there is no change, then I have a problem, I think. 26. And there is 13. No, it should be fine. Of course, I need to divide by the sorted numbers. Huh. Silly mistake. Yeah, makes sense. Yeah, now it makes sense. You can sum this stuff. Should be everything right. Now, we not only have the problem that we have those values here, we now also have a limit of numbers. So a bank does not have all the nodes you might need. It has also here a limit of numbers of nodes you can get. And since the other levels are dependent on this level, I might want to create a lambda for this. And I could start with making this to a lambda, but I think I write it from scratch. So lambda, I have an amount. There's my start amount. I have the values and I have a limit. So, and then I start with my let function because all three inputs I've done yet. So now I want to have this sorted and I want to have the values sorted by column and I want to have the limit sorted and sort by. I now need sort by because I need to sort the limits by the values minus 1. So now I have my inputs ready. And I start with getting some stuff from here in. So this is sorted, this is sorted, but I need here the amount and then the scan amount. First to do it without the limit and from there on I will start with including the limit. So it's a multi-step approach. So scan, it's included here. This is the amount and this is my sorted array. So val s. Lambda AB is fine. And I get here nothing because I don't have any inputs. Can also give it the limit, although I don't have it. But here we have this here. Now I take the amount plus drop of the scan minus the scan and divide it by those numbers here. Name this as C. This is a stack amount and drop SC the last column, and this is SC, and these are the values, if I were values sorted. Something wrong. Divided by value sorted here. Okay. Yeah, there's also something here. This is full SC. Okay, let's copy it in again. SC is done. So this is a stack amount plus drop SC as column minus SC divided by sorted values. Okay, I know what my problem was. I haven't closed the 8 stack bracket early enough. And now we have still a problem left because we don't have any limits yet. So here I also want to include the limit, but I now have a problem because I only used scan here. And I want to have this adaptable. So SQ is a sequence of columns of one of the inputs that is an array, so val. And now instead of val s, I'm using SQ. And now my B is SQ, so 1, 2, 3, 4. And here I exchange my regular B now again against index. In this case, it is was it the value or the it's the value. So val s semicolon b close bracket. I also need to exchange the other b. Some bracket problems. Oh no. Now we still have the same, but I can now also include with my sequence the minimum, so the limit. So this here is then minimum of this or index limit s and b. And now 17, 18, 18, 1, I get to the result. We can sum this. Yes, this is the last argument. Sum And we are at 55. And also get a result and the right result for all the other levels. Now we need to start with multiple solutions or multiple ways for solving this. And I want to use a data table for this. So I start with my data table macro, please for level 5. Here we go. I now need to only use those banks and also not the example here. So I'm only using these banks here. These banks here. Copy. And I don't need really a data table for this, if I'm right. Oh no, I need it. Okay, yeah. Okay, here we have first for all the banks was it first the values or the nodes? The node and then the limit of nodes. So I want to split this into groups with choose calls, sequence. I know that it's 7 columns. And now I will only have the values. And let's also use the limits with another choose call. Now I have the limits and the values for a single bank. And I now can elaborate on the lambda I've created for prior levels. Here we go. My amount is given here. My limit is given, my node is given here, and my limit is given here. And now I get to the number of nodes I need for this. Yeah, I should fix this reference. And we now have the number of nodes and the banks, and then we can sort a stack, bank, and number of nodes, and sort by the second column. And in this case, we should now use the placement tool, which is the pivot finance bank, which is also our placement tool. So I use the index of the bank array, second row, and there is in between a double point and index of the number of nodes. Let's create a data table based on this. Notice a little bit of calculation. And I'm getting a result for level 5, which is right. Now, let's turn off the data table here. Properties calculation off. Because level 6 will get even more trickier, or kind of. So, we have various project by the bank. So, for each project, we want to withdraw money from the bank. We can use every bank only once for each project. And we want to withdraw money in the most efficient way, so to say. So I did it that I did separate sheets for the separate projects. Then I think it was the same for level 6, except that we're also using example bank 6. So I'm kind of I have kind of copied this here in, not in the, yeah, here we go. In this corner, and now also including example bank. Example 6 bank. Oh no, sorry. I was wrong. The example 6 bank is only used for the example. Yeah. It's a little bit tricky with this input based on level, so yeah. But then I don't need to keep this in mind. So, and we have different values we want to use in amounts we want to use in project 1. And I can exclude this amount here even if it's from project 1 because it's the example bank 6 and we haven't even, or we will not use it here. So, yeah. And I'm now using the formula, and sorry for the bad, for the bad, for the bad appearance here and there. It's kind of hard working my laptop. Fix the columns, fix the columns. Ah, no. Okay, let's calculate. Why are you not calculating? Yes. Because I have fixed the rows where I wanted to fix the columns. Here we go. And now I need all permutations because I have no algorithm to say, okay, this is the first bank, then this is the most efficient bank, number 2, and so on and so on. And therefore I'm brute forcing it. And yeah, I recently fixed my permutation lambda. So we have 6 numbers, 150,000 combinations, not that much. Index. No, we want to have the amount here. And now I need to fix the rows, and this is the row given. And then I can track it. I'm able to track it aside. Yes, I know. Calculate shortly. And I can use by call, no, by row sum to figure out how many total nodes I would use if I would use this combination. Min match. Where is the smallest combination in row or relative row 7,2000, and then I use index. No. To figure out the banks used. These are the banks used, and these are the nodes I used. Let's make the banks visible. Wrong direction, the other way around, but easy fix. And we can simply concat this. And we get to our results. Now I need to both transpose and put only values in. Please save it. And then I basically do the same for project 2 and project 3. 6P2. Project 2. So this is a semi-manual approach. Project 2 is given here. Expose it. And copy this in here. Okay. Now we need to think that we have now not lost a value due to the example. So we need to calculate 7 numbers. So I need my larger permutation, or the same lambda, but instead of using 6 numbers, I'm using 7 numbers. Here we go. And then again, index, and a row number. Okay. 7, yes. And this now will take a short minute. You see, there is, of course, a more elegant approach. There are, of course, some algorithms you could use here, but I'm not a programmer. I'm not a data scientist. I'm not a mathematician. So I do not know those algorithms. And when in doubt, either zoom out or brute force it. That's my approach. Not always the most efficient approach, but it will lead to result more often than you think. Here we go. No, we're not going there, still calculating. And since I'm kind of here, do not want to crash Excel like I did multiple times before, I will wait. Okay, here we go. By row sum. Okay, I think that before doing this, I will turn off the calculations here. Properties, turn off calculations. Yes, okay. Should be a little bit faster then. Min match to get to the relative row. Index of this array here to get to the bank. Yeah, sorry. Alexa gradually calling. And I can't mute her. No, she's still. So then index of those banks here. Now we get to the bank name. Hello. Oh, you see calculation heavy and index or not the most efficient approach, also possible. This row and the whole column as an output. Bank and Let's calculate. It will calculate. Here we go. This is then the answer, or these are the answers for project 2. Here we go. And now first turn off the calculations here. And use a third sheet for the third project. You see, Excel is on limit. Okay, case. Take those. And use the formula that is written here. And since it's written for those numbers, I can simply drag it to the side and drag it down. Now, permutations array up to number 10, 7 numbers. Will take a second. Okay, 30 minutes in. Okay, here we go. Index of those arrays, row fixed, or number given here. And it will calculate for quite some time. And we will wait. And hopefully nobody will disturb us, like some home assistants. But let's see. Anyways, my challenge, not my challenge, my channel had his birthday yesterday. This channel is now 1 year old, or a year ago I posted the first video. So that's the birthday. Yeah. We celebrate with a hard case. Yeah. I have planned something else for this, but it would take a little bit longer, but stay curious, it's a cool thing. Anyways, we have calculated, yes. By row, sum. Here we go, min match. It's on row number. Hello. 241,000. Index to get the bank names. No. I was too fast. Whole column. column. Now we get bank names after some waiting time. I think I should click Control S in the near future. Index. Bank names. Wow. My machine is getting slow. Super slow. Very slow. Index to get the amount of numbers. I want to have the whole row. And then it's calculating this and this. Okay, it hasn't calculated properly, I think. 191 for everything is kind of odd. Ah, yes. I'm so idiotic. Okay, here we go. Sorry for that error, of course. I then need to use the row here. Okay, here we go. Copy this in. And we have solved, at least, hopefully, in the near future, all the levels. 270 points in, 100 points to go. Turn off calculations here. Okay, now I can do first bonus 4 because it's on the easier side, because we've done it there 1,400, 841 ways to get to the same number of nodes for project 2. And we have all the nodes for project 2. So I use here group by on all the node combinations. I was too fast. And count, because we're counting numbers. And I, in this case, want to have it sorted. And then I search for the number where I use 1,841 ways. It will not calculate because I've turned off the calculations. Great. Now it will calculate and it will take some time. Okay, it will take ages. And I think I've crashed Excel. Have I? Okay. Let me quickly check. Calculating 0%. 30 threads. But I think we're running. So it will take long. Okay, I think I will skip over the waiting time somehow. Although I don't have a pause button anymore. Ah. Okay, it has calculated. Great. So here we go. The number we are searching for is 949. Turn off the calculations. And I also have saved the file, so 949, which is should be right. Yeah, it is. Okay. What is the most common node offered by banks? Let's go to the bank table. Okay, bonus 2, we should all of them. Group by, oh no, that's first data. To call choose false. We have 7 columns. Step 2. And now group by the count -2. And here we have the 1 result, but I want to see the table. Okay, we have a spill result. And the most commonly offered node by banks is it is crashing. 1, which is offered 21 times. Okay, I will first do bonus 3 and then bonus 2. So, how many nodes you will receive are less than or equal, or in this case, less than 11. Examples not considered and only for level 1, 3, and 4. So, since all nodes are less than 11 for level 1, I take the whole answers. And here I'm in a sum, so I simply filter the results here. If no, I can't filter that way. Okay, let's lose this first. It will be wrong, and then I prepare the level 3 and 4 answers. If Excel isn't crashing. Okay, here we go. Level 3. Is this 3? No, this is 4. Yes, 3. So, this data table. L then 11, less than 11. And I want to filter some filter those numbers if the sorted denomination currencies are less than 11. Yes, accept. 10. Okay. Haven't I turned off the data table? No, I don't think so. Okay, here we go. It hasn't calculated yet, but it will be, and then we have prepared level. We prepared this. Okay, here we have used our formula, but as you can see here, there's only one instance where a value less than um, 11 is used and it's always at the end, but we can still use SC. I think SC it is. And then SC and val S. So I thought it will use. Haven't I turned off this here? Oh no. It's turned off. Interesting. Okay. Calculation options. Okay, back to the case. Okay, here I have the value. Ah, no, these are the values. Da, 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 da. What can I do here? Okay, these are the scanned amounts. Minimum of this is SC. No. SC are the amounts that are left at the end. And now, how should I tackle this? That's a problem if you ask them something in the bonus questions and you've done it single cell. Okay, SC is, oh, how often those nodes are used. Okay, makes sense. And then I simply filter val S by if, oh no, I filter SC by val S smaller 11 and I sum this. Why is this wrong? Oh, that was the first. Could be that we get in an error here. Yeah, no, 0. Should be fine. Okay, track this down. It's bad. Okay, do we always have a 0? We've never used the 1. I cannot imagine this. Question is why? Ah, this Excel is so crashy. Ah. Okay. Yeah, of course. No, it should be fine. SC is the number of oh no, I should use this here. Is the number of nodes used. So some this. Okay. Now let's hope that this will help. 26, here we go. Let's calculate and then hopefully we get to the result. Okay, could be. Okay, add here level 3 answers and level 4 answers. Okay, and let's see what the result is that we will get. It's right. Yay. Now, bonus 2 left. You were to withdraw all amounts from levels 1 to 6 without examples in one sum. So, all amounts from levels 1 to 6. And I have prepared this with my bonus copy, so this is the amount. This is the amount we want to withdraw in one go. 40 to whatever quadrillion. Oh no, it's only billion. 400 billion. How can I get this sum to my bank account? Just asking. Okay, in one go, you withdraw from the bank with the least money reserves and then continue ascending. So here are the banks. Okay, this is something else. Choose calls, sequence 7, step 2. I hate this bracket stuff. You make some complexer formulas. Okay, here we go. These are the nodes and these are the amounts. Okay, let's calculate, please. Calculate. Bill array and so on. Okay. Where will this be? Oh, of course. And I need to call this. And also to call this here. Okay, why does this take so long? Okay, here we go. Or not go. We go like a slow animal. I don't know the term for this, like weirdly slow animal. Okay, and then we need sequence. How many banks do we have? 30, 21 banks. Sequence 21 times 7 divided by 7 and round down. And then we get the bank number next to the nodes and the amount. Round up, sorry. Round up. And then we get to the result, or at least to the bank number next to those amounts. And now we group by and values are group by the bank, and our values is a multiplication. And since we have dynamic arrays, we can do this. And then we want to have the sum, no headers, no totals, sort order -2. No. Okay, this will take a second. And now we have the banks and how much money you have withdrawn from them sorted, and this is then the bank order we use. And We need to withdraw there this amount. And I can now uh, show you something. Scan and lambda. Oh no, much stuff. Lambda a b a a minus b to get a running total or a running subtraction total. And you see here, we only get to a negative result at the last bank. So this is our starting point. And because we withdraw money from every bank above, the full money amount we can get with the limited notes. And from there on, we only withdraw from bank number 15 in the sorted order, so largest node then lower node, bank number 15, and I then simply are able to copy this here. I want to transpose this, of course, and only want to have the values. But here we have the node and the limit then, and we need to withdraw this amount. And now we elaborate on the formula we've used on the former levels. So this formula here, this lambda, yeah. Okay, please enter here. Amount, nodes, limited nodes. And then I get to 13,771 and all the nodes from all the other banks. So this is plus filter this if the bank is not 15. So we calculate shortly and then we hopefully get to the answer in an instance. Yeah, of course I need to sum this. Yeah, makes sense. 42,000. So a large number. Let's check it. And it is calculating. It's right. Yeah, we've solved the whole case in here, I think over an hour with some technical issues and nearly broke Excel. But we're finished. Yeah, thank you for your attention. I hope you were also able to tackle this case. It was on the harder side, I can say. And yeah, thank you, Jean, for this case. See you in Leipzig and hopefully Vegas. Bye.